Hello everyone, this is Vasant, a 9-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to discuss about stress strain diagrams of a ductile material and brittle material. So we already completed the stress strain diagram of a ductile material in tension. Now let us discuss some more concepts of that stress strain diagram. So we already know about elasticity and plasticity, right? So elasticity means the material stiffness to the deformations. Plasticity means the amount of permanent deformations that can happen in a material. So we already know how the stress strain diagram for a ductile material will look like. So now let us understand after we are loading, but what happens if we unload? So in the region OA is the region of OA is elastic region. So if we reload, if we unload before increasing the stress after elastic region, then the material will regain its positional shape in the same direction on which it behaves in loading. Means, see, on loading the stress strain diagram look like this. On unloading also the stress strain diagram will look like this. Means it will follow the same path in reverse direction. Okay. So this is about the unloading case in the region of elasticity. So now let us go to the region of plasticity. So if we go to the region of plasticity, let us assume the material. Generally, the material is not perfectly plastic. So let us take the diagram of partially plastic material. So after E, this is yield stress. After E, there is plastic deformations. So we are taking some particular point. After that stress, we are unloading the load. Then it will again regain its shape. It may not regain original shape and size, but it will regain some of its strain, right? If you see the diagram on unloading, it will follow this diagram. So this is the recovery, this is the elastic recovery, and this is the residual strain, means the strain left in the material, in the strain which is permanent in the material. So how the material is following this path? Because see, whatever recovery is happening, that is of elasticity. So if you take the tangent to the stress strain diagram at position O, that line will be parallel to this line. So suppose this is O dash, then O dash will be parallel to BC. That makes sense, right? Because the recovery is of elasticity. Whatever elastic strain is there, that will recover on removing the load. So it should follow the path of a elastic recovery. So it is parallel to the slope of the tangent at the position O of the strain diagram, right? So this is elastic recovery, this is recovered, and this is residual strain, that is permanent. This is about loading and unloading. So if you again after it reaches this position, if you again load the material, then this will be elastic behavior for this material. So it will go like this, and it will move something like this. Okay. Again, if you reload, it will come like this, and again if you load, it will go like this and go like this. Okay. So this is about loading, unloading, loading, unloading, loading. So now let us go to the brittle behavior. We already discussed ductile behavior. We said that in ductile behavior, after elastic limit, the material will have more strain before failing. Okay, means it will give some signals to us before failing. But in case of brittle materials, after elastic limit, after certain increase in the load, it will fail suddenly. So the diagram, the strain diagram typically will look like this. This is elastic region. And this is sigma ultimate. So after this, that will be Emax. So see, we said that in ductile materials, the Emax is different from the sigma max. Means if you take the graph, if you look the value of strain at the position of sigma ultimate, that value is not maximum. But in the case of brittle materials, the Emax will be is equals to E ultimate, right? But this is in the case of brittle materials, right? But Emax will be greater than E ultimate. Here ultimate is of sigma, okay? So in case of ductile materials, okay, this is about brittle materials. The basic examples of brittle materials are concrete, chalk, etc. Okay. The ductile materials examples are steel, aluminium, copper, mainly metals. The cracks propagation in tension. Let us see this. See, if you take a rod, if you take a bar which is made up of brittle material, suppose there happen a small crack in this in tension. So see around that position, now the area available in this region is less than A, right? Suppose here area is A. Then around the crack, there will be stress concentrations. So the sigma will increase around the crack, right? So because of that, the crack will propagate, means the crack will increase. Again, the sigma will increase. Again, the crack will increase. Again, the sigma will increase. Again, the crack will increase. So like this, it will propagate and suddenly it fades. So this is the crack propagation in tension. But if you take compression, it will try to compress the crack created. So in compression, the brittle materials are hard, means they won't fail easily. In ductile materials also, in case of compression, they won't fail that much easily. Okay. So this is about brittle behavior, stress strain diagram of a brittle material. Now let us see one thing: order of reducing weakness for ductile materials for tension, compression, and shear. Okay. So what will be the order? The order will be the order of reducing weakness for brittle materials, same for tension, compression, and shear. Okay. So if first we will deal with brittle materials. So in brittle materials, we already said that the cracks will happen in case of tension and that will propagate and the material will suddenly move. So the first will be tension, and we already said that in case of compression, whatever crack developed that will close, it will contract. So that will increase the strength of the material. So the compression should be last. In between will be shear. And in case of ductile materials, if you see, we already discussed about necking. The necking will happen on 45-degree plane. 45-degree plane में क्या होता है? Maximum shear stress होता है. So इसका मतलब है कि the ductile material will fail in shear. So it is weak in shear. The reducing weakness will be shear greater than next क्या होता है? Tension. Next compression. Right. So in case of compression, both ductile materials and brittle materials are hard, means they are strong. But in case of shear tension, they shuffle in case of shear tension. Ductile materials are relatively more weaker in case of shear, and brittle materials are relatively more weaker in case of tension. So that's more weaker. Okay. More. So from this we can say that ductile materials fail in shear. Brittle materials fail in tension. So see, if you take a piece of chalk that is brittle, right? And you apply tension on both sides, that will fail in this plane. But if you take a brittle material, sorry, if you take a ductile material and you apply tension, increase the tension, then it will plane in 45 degrees, this and this. Okay, so 45-degree plane. So with this we end today's lecture. Thank you.